do page 33, problem 2.3. You guys are work 5 minutes alone. Then we'll compare answers. Do all your work on your clear view. So don't write it in your comp book yet. Okay, stop for a minute. I'm hearing some good questions. But one of the questions I'm hearing is, how many people are there? So if we read the problem about Jane and her friends going on a hiking trip, Jane wants to make snack packs to take on the trip. She has 24 apples and 36 small bags of trail mix. Okay? Each snack pack, they're kind of like party bags, snack packs, or lunch bags. And she's bagging up lunches for everybody. Okay? Must have the same number of apples. That's what it says. Each snack pack must have the same number of apples and the same number of bags of trail mix. So on your clear view, basically what the key information is, what's some key information? Something important. Yeah.
We have 36 trail bags and 24 apples.
That's right. They have 36 bags of trail mix. So those, and I'll just say TM and 24 apples. Okay, good job, Sean. It doesn't matter how many people there are, because that's not what the problem's about. They're just asking how many different sets of bags could I make. You cannot have leftovers. That was one of the questions. Any other questions? Jack, sorry.
Couldn't you just do 24 packs, just putting one in one of both of these pieces in one pack?
Okay, he's asking, could I have 24 like snack bags? If you had 24 snack bags, you could put an apple in each bag, and then you could put a bag of trail mix in each bag, but you'd have leftovers. So you can't have leftovers. So, like, just read one example that would work. Okay, so one possible solution, and then I'm going to let you guys work a little bit more. Is what Discrete said, that you could have 6 bags with how many apples? 4 apples. And how many trail mixes? 6. And 6 trail mixes. And why is that?
You have 6 bags, 6 squares, 24.
Right, this makes 24, and that's how many apples there are.
6 is 36.
And this, when you multiply these, makes 36. And that's how many bags of trail mix. So that would work because it would be divided evenly with no remainders. Raise your hand if that makes sense. Okay, so I see some of you guys. What about this middle table? Okay, what's the question then, Emma? Isabel, you have to ask a question.
Well, I'm trying to figure it out because I did the ladder.
Okay, so the ladder would give you one solution, but they're asking you for all the possibilities. So we're going to look at the ladder in a minute, but that one's only going to give you one thing, okay? So you're trying to think of all the different combinations. So in this case, you might use a list. Are we interested in factors or multiples? Emma? Factors, right? Because we're breaking these numbers 24 and 36 into smaller groups. So maybe the work to solve this problem would be to list all the factors of each number. How about if you did that? List all factors of 24. Finish this list. And all factors of 36. Make 2 lists. And see why I'm asking you to do that. Maybe that would help you. How many people have some, maybe all the factors of 24? Raise your hand. Okay, most of you. So Finn, read them off to me. What do you have?
1, 2, 3, 4, 6, 8, 12, and 24.
1, 2, 3, 4, 6. I'm going to write them in factor pairs. You said 8, right? 3 times 8 is 24. 12. And this would be repetition, right? Does that make sense? You guys, did we miss any? No? Okay, Kate, factors of 36.
1.
1 and 36. How about 2 and? Good.
And 3 and 12.
3 and 12. Good.
4 and 9.
4 and 9.
6 and 6.
Done, right?
And 9 and 4.
So that would be repetition, right?
Oh.
Remember if you make that organized list? Okay, Bella, why do you think I wanted you to make a list? Yeah. So, did you guys hear what she said back there? Okay, we'll have her repeat it. I'm asking her why did I have her make a list, and she said so you can see which ones go together. For example, what? Okay, she said, for example, 4 and 6. What I would say is, if you knew that 6 was common to both, you guys see that 6 is common to both? Then the factor pair, that means you'd have 6 bags, because both of them can be divided equally. And the factor pair is what Bella's saying. You know that 4 times 6 makes 24, so if you have 6 bags, you have to have 4 apples. Does that make sense? And if over here you know 6 times 6 makes the 36, this is the trail mix list. So if you have 6 bags, you have to have 6 sets of trail mix in each bag. Or 6 trail mix packets in each bag. Questions? Richie? So if I were going to just ask you another combination, Devin, what's another combination? Like instead of 6 bags. I just talked about it. Want to give an example, Isabella? Isabel?
No.
Question, Aiden, you want to give it?
Then combos maybe 3.
3 what?
3 times.
So could you have 3 bags, or do you,
Oh.
how many bags? We could divide, Scout?
I did 3 bags, and then you have 12 bags of trail mix in one. And
Okay,
then
so
8
you,
apples.
because 3 is a common factor, we could have 3 bags, and in each one of those 3 bags, what are you going to have, Scout?
Well, and
Look at the
all of
list.
them, they each have 12 bags of trail mix,
They'd have 12 trail mix,
and then 8 apples.
and then 8 apples. So is this list helpful? Yeah, and what I want you to do before, well, let's go back. So Scout, give an example now. What's another one? I mean, Devin. What are we looking for, guys? Common multiples or common factors? What do you think, Devin? Are these factors or multiples here? Look at my list here. Are they... Yeah, and you can still answer factors and multiples, I bet. I'm going to come back and call on you. Okay? Be ready to be called on and come up with an example. Charlie.
You're looking for the lowest common.
Well, I'm not necessarily looking for some factors because it asks for all the combinations. I already have 2 factors. So what's another combination?
2 and 6.
2 and 6. 2 and 6 what? 2 what? 2 apples, then
Trail mix bag.
so if we had 6 bags, we'd have to have 4 apples. So we already have 6 bags. And then we said if we had the one that Scout came up with, just to show you, because 3 was a common factor right here, you could have 3 bags. But then it would have to have, Bella, what would it have to have if you had 3 bags? What was your idea? How many apples? 8. Where is she getting that from? Sean, where's she getting it from? Because 3 times 8 makes 24. She's getting it from the factor pair. 8 apples. Hold on, and I'll answer that, Jack. And okay, but how many trail mix packets would be there if we had 3 bags? If you have 3 bags and you only have 4 trail mixes, that's only 12 packets. You have 36 packets. Look at the factor pairs. 3 bags tells you how many trail mixes. 3 times what makes that 36? Yeah, so you'd have 12 packets of trail mix. I'm not sure you guys are seeing this. Okay, Devin, try. So we could have 6 bags, we have 3 bags. What's another combination? What's another common factor? Look at there's a whole list of factors here. Give me the common ones. 12's common, right? What's another one? Just looking at my list, what are the common factors? Let's circle them. Is 36 a common factor?
Yes.
Yes, in both?
Oh, no.
No. Is 18 a common factor? Is it in both? 18's in both?
No.
No. How about 12? Is 12 a common factor?
Yeah.
Okay. So, Devin, can you make 12 bags then? Yes. So how many apples would be in that bag? Look at the factor pair. Let them do it. Look at the factor pair. If you have 12 bags, you have to divide the 24 apples into 12 bags. How many apples would be in each bag? You're taking 24 apples and you're breaking it into 12 bags.
3 bags of trail mix and 2 apples.
Perfect. You see where he's getting that? You guys see that? You have 12 bags, you have 2 apples and 3 bags of trail mix. Any better? Okay, Chloe, what's another combination? Could we have 9 bags? No. Could we have 4 bags? Because 4 is a common factor, right? So Jacqueline, if we had 4 bags, how many apples would be in each bag? No, because 4 times 2 makes 12 and we have 24 apples. 4 times 9 makes 36. We only have 24 apples.
I got it.
6. So look for the factor pair, right? 4 times 6. So if we have 4 bags, we'd have 6 apples. And how many packets of trail mix? 4. If we have 4 bags with 6 apples, And because 4 times 6 makes 24, there's 36 packets of trail mix. Right. 9 packets of trail mix. Better? Okay, Jake, can we do 3 bags? I mean, we did 3. Can we do anything else? Did I skip one? I see 6, 3, 4. Would 2 work, you guys? Is 2 a common factor? Yes. Anything else? You can have 2 bags. 12 we talked about, right? So here's the thing. This would be a good time to organize this in your comp book. And in your comp book, I think what would make sense to start with is this. I'm going to give you a few minutes to copy it down, but then what I'm going to do is I'm going to make a chart. Sometimes a chart, once you understand the problem, is more useful. So let's go to the comp book and set it up. And add to it a little bit. I'll pause it. Okay, so let's make it a little, we're going to make it a little more organized now, right? We talked about the problem. When you solve a problem on scratch paper, it's a thinking process. A good way to organize this, what I think would be nice is if I made a chart, and you made a chart, you'll be able to read right from the chart, because this is helpful, but it's not easy to read. But it's the thinking we need. To make it easy to read, what if I made a table that said the number of bags, and I use the pound sign, number of bags of snack bags, right? And then number of apples. What would the last column be? Number of what? Yeah, Richie. Trail mix packets, right? So I'm going to choose TM. If I made a chart, I bet it would be more helpful for you. After you write all those common factors out, on the left side of the page, we've circled the common factors. So every common factor could be a bag. I mean, we could have 1 bag, but it would be kind of silly. Because if I only have 1 bag, I have to have all the apples and all the packets of trail mix.
That'd be a big bag.
So this doesn't really work for the hike, does it? That's not really the goal. So that doesn't work so well. So it's not great for the hike, right? So we'll just, not great for the hike. Not for this problem. But all of the other combinations should work. Like if I have 2 bags, I look over here and it tells me that I'm going to have how many apples? 12. And then I go to the other list and it tells me how much trail mix. How many packets of trail mix? If I separate it to 2 snack packs. Charlie.
13.
2 times 13 is only 26. 18. Okay, Richie, what about if I have 3 bags? How many apples?
8.
There we go. 8 apples and 12 packets of trail mix. Finn, what if I have 4 bags?
6 bags of apples.
Yes. 9. Do you get this, you guys?
Yeah.
Okay. I'm going to stop there. Okay, so if we just, I'm going to go ahead and finish the problem up. We're going to look for the other common multiple. So we've already done 1, 2, 3, 4. You could also have 6 bags. Then you would have 4 apples and 6 packets of trail mix. And then finally, you could have 12 bags with 2 apples in each bag and 18 packets of trail mix. Those are all the combinations. So on the next part of the question, A number 2, they ask you what's the most number of bags that you would have. Since the list is nice and organized, you can see the most number of bags is 12. So Jane can have at most 12 bags. With 2 apples and oops, look at my mistake here. Oops. 12 bags you have and 3 packets. Of trail mix in each. So, even though the list shows all the combinations, if you aren't asked for all the combinations and you're just asked for the most amount of packs you could make, I saw some of you guys using the division ladder, and that would work if you don't need all the combinations, and that's where I'm going to end today. So if you had apples and trail mix, and you knew that you had 24 apples and 36 packs of trail mix, the ladder is a really nice method, because then you don't have to have all the lists if you just need the most number of snack packs you can make. So you can just use the ladder, and the ladder method just takes out those common factors. For example, 24 divided by 2 is 12. 36 divided by 2 is 18. And you could say 6 goes into 12 and 18. 6 goes into 12 twice, and into 18 3 times. Now, since 2 and 3 only have 1 as a common factor, you know your greatest common factor is 2 times 6, which is 12, and that gives us 12 snack bags. But what's really nice about the ladder is the bottom of the ladder tells you how many apples. Look at the bottom of the ladder. 2 apples. And how many packages of trail mix. I'm abbreviating packets. So in summary, this Viking Snacks problem had you list all the combinations on the left side of the page, and we got that from starting with factor pairs. Then we circled all the common factors. Then we used those common factors to decide how many snack packs we could make. And then if we only needed the most amount of snack packs, even though we could do the list, we could also use the ladder.